Hello everybody, my name is Jay Yu. I'm the VP of Product Innovation at TigerGraph. Welcome everybody for day 2 on Graph+AI Summit. For today, I'm going to talk a little bit about progress made in TigerGraph to democratize Graph for all. You heard a lot from our CEO, Yushu, and Todd, our COO, talk about our journey to make Graph available to everybody. I'm going to show you the how we made that happen. But before I do that, I'm first going to talk about some quotes from Gartner. According to Gartner, by 2025, graph technology will be used in 80% of data analytics innovation. That's up from 10% from last year. That's a rapid growth. To graph or not, that's not the question. You will graph. How do we project this to the technology adoption curve? This is a famous framework done by Jeffrey Moore in his book, Crossing the Chasm. They literally say when a new technology product goes to the market, you have to go through different phases. The initial phase in the early market only talk to those innovators. Unfortunately, it's a very, very small, tiny portion of that. They are the one usually jumping to do whatever needed to play with the bleeding edge. Then comes the visionary you want to target. Those people with big strategic goals understand what business need and they see what's coming in the technology and connect the dots. They are the champion to bring brand new technology to the organization for business success. Now, that's still not a majority. Unfortunately, that's only 15%, less than 20%. In order for technology to cross the chasm, you have to cater towards the practical side of the house. These pragmaticists, they actually insist they have to see real proven value, real proven technology before they can adopt. When you win them over, then you can over the hump. And those conservatives look at how everybody else is doing. When more than half of the people are already adopting the technology, they will follow. That's where you reach mass market. So 10% in 2021 is about a little bit middle of the visionary. 80% is about you reach majority of the conservative. We're absolutely crossing the chasm. I can tell you why. Number one, if you look at the growth in graph database interest, this is captured by dbengine.com. Graph database outpaces any other graph technology by a lot, and it's not stopping. And if you look at all the graph use cases, we are seeing the growth. A few years ago, we're only seeing probably half a dozen. Now it's more than 16, and the list kept growing. The $1 million context also exposed us even more use cases than we ever imagined. So this is incredible growth. Let's also take a look at the data size growth. That's a huge indication of whether people are using Graph for real production use case at scale. A few years ago, it started with only 100 to 500 gigabytes. And 2 years ago, 2020, we're seeing 500 gigabytes to 1 terabyte range use case. Guess what? Last year, we're seeing, the use cases, the production deal already go to 5 terabytes. And we're already seeing new deals coming in at the 10 terabyte range. And customers are already talking about, can you deal with 70 terabyte? And pretty soon we'll reach 1 petabyte. Now with that kind of growth, I want to tell you why. Because we have the technology to make sure you can grow like that. TigerGraph is the scalable ML analytics graph platform for growth. If you look at that in the middle, that's our core parallel database technology designed, optimized for graph. It's available on-prem as well as on the cloud, on all 3 major clouds, from AWS to Google Cloud as well as Azure. And underneath it, it's this massive parallel data architecture. Not only supports short, sub 100 millisecond OLTP transactions, but also support massive OLAP queries, can basically process terabytes or multi-terabytes of data. It is lightning fast. It can scale horizontally, almost indefinitely. You can scale from a cluster of 10 nodes to 100 to 1,000. That's our secret to support the data growth. And finally, the data is compressing the way it's very easy, very cost effective to store and process. But on top of that, we developed 4 pillars to make it really, really easy for people to adopt. I'm going to go through that a little bit. In order to make sure TigerGraph actually work in the context of end-to-end ecosystem, we allow you to connect as many data sources as possible to ingest data into our platform. We have many, many data connectors, can connect to the relational data sources, NoSQL data sources. You can load from CSV file, Avro file, and so on and so forth. Once the data gets into the TigerGraph database, whether it's stored on the cloud or on-prem, we give you the ability to write sophisticated logic or queries. It's called GSQL, as well as using a Visual Studio-like developer tool to simplify the development, deployment of graph solutions. Also, we give you a RESTful API to integrate your UI application to TigerGraph. But that's not all we can do. At the same time, we allow data to be streamed out, to be exported, to go into the downstream machine learning pipelines, as well as taking advantage of existing BI tools like Power BI Builder, like Tableau, and so on and so forth, Looker. So one of the key distinguished advantage for TigerGraph is its performance and scale. And this is rooted in this fundamental architecture called parallel share nothing architecture for massive parallel processing. We organize data together with compute and distribute among a huge cluster of nodes. And the way when you ingest data to our system, we automatically partition them across many, many nodes. And when we want to do compute to do deep link analysis or apply graph algorithm, all these nodes can do the computation in parallel. That's how we can scale. And this architecture make it very easy for us to also create high availability clusters, making sure even one of the servers down, your computation, your processing is not impacted. We are the first and the only vendor to complete LDBC SNB benchmark at 36 terabyte level. That benchmark at that scale includes 73 billion nodes, 500 billion edges. It's massive, massive amount. And a lot of other vendors are struggling at 1 terabyte level. That shows the superiority in terms of performance and scale. The other area is once you have the data ingesting to the system, you need to be able to process it. One of the challenges for a lot of graph adopters is the traditional or the alternative graph query language usually is very foreign to millions of developers already familiar with SQL. That's how we actually create a very easy language called GSQL. It's called Graph SQL language. Basically, it's built on top of SQL, retain all the syntax like a select from where, but instead of selecting from tables using where clauses to join them together, we allow you to select from path. That's a very natural way to traverse the graph connectivity, right? The relationship. In this picture, as you see, the graph schema is visual. It shows how a person can purchase a product have features, and then what the payment is. So this particular query allow you to select the path is how do I coming from a person buying, basically have an order, and the order includes a product. And then you can have where statement to specify what kind of criteria you're looking for. And we also give you a very powerful accumulators construct in order to aggregate the data. Also, you can use this powerful Turing complete language. It combines both procedure and declarative power together for you to implement really sophisticated graph algorithm. And this is an example of PageRank, which is a secret behind Google. How do you know which website is the most influential, right? Referenced by a lot of people. That PageRank algorithm can be easily coded in 10 lines of code like this. We also provide a built-in graph data science library with 50 plus algorithms that includes shortest path, centrality, that's the page rank, try to understand the influential, find influential people or product and so on and so forth. Similarity algorithm to help product recommendation, classification and community detection is all built-in unsupervised machine learning. As you heard from day one, Microsoft Xbox talk, community detection algorithm like Levine can be really effective to detect the active community among 100 million gamers. We also added some new capabilities to allow you to predict links, to allow you to compute graph embedding, bring contextual information to the features, to your machine learning model, so your model can be a lot more accurate, as big as 50% improvement in the overall efficiency of your model. The other area we provide is making sure there's a graphical way to explore the data in the system. And then also there's a way for you to draw the visual pattern. Instead of writing G-SQL language, you can visually draw the pattern and will automatically translate that into code to execute for you. We added enterprise-grade capabilities because more and more enterprise want to depend on TigerGraph for their mission-critical app and mission-critical analytics. And also we attract hardware vendors work with us closely to add the much needed hardware acceleration to actually speed up those graph algorithms up to 1,000 times. Land Rover Jaguar used TigerGraph on the commodity CPUs, able to accomplish a supply chain management optimization, reduce the planning time from 4 weeks to 45 minutes. With this hardware acceleration, you can reduce from 45 minutes to 3 seconds. That's game changing. And that's why Dell and HPE are working with us to build graph appliances to make sure it's much easier for big enterprise to take advantage of the full power of graph analytics. Now, what I want to share next is really the exciting part. While we already have all these great technology to support enterprises to bring their data to knowledge, to greater insight, we're not stopping. We have more innovation coming. And the first area is, can we shorten the graph adoption with ready-made solution app? Reduce the time to value from months to quarters, month or quarters to days and weeks. Can we do that? That's innovation. We can actually do that. This is an example. We developed an application called Data 360. The idea is to keep track of the data journey, how data travels from operational store to data lake, to data warehouse, and finally in your mission critical report. We show the healthiness of the entire system, how many of those reports depend on what data set, going through what jobs to make the linkage together. We show you the graphically, visually, how these dependencies happen. If something has some issues, delayed, or the report is not available, you can track down what are the dependencies. You can also see a schema change in one set of data set, what's the downstream impact? You can do impact analysis. You can also easily see the history of what events happen to what part of the system. And you can use machine learning to predict the future stability of your system. Allow you to search what's there and allow you to examine what's going on over time. So that's an example. We can shorten your development cycle. What's underneath it, we already have pre-built generalized schema, queries, as well as the end-to-end application stack. Not only about the graph database, but also the service layer, the client tier, the UI experience you just see. And also there's a way to ingest data, both from a batch point of view, as well as streaming to keep track of the latest event. And finally, there's a way to actually notify you when something happened and allow you to view everything through application. So the next area is equally exciting. It's really about how can we simplify analytics and visualization so that non-technical people can easily do it without a lot of knowledge. And let me show you an example, a demo of one of the new tools we're developing called Nala. It's a no-code way to do visual graph analytics. So you start with a builder. When somebody, a data scientist, a business analyst want to build this dashboard to be shared with executive business users, they start with this interface. We allow you to just click, configure, drag and drop. You can start building up input parameters, the control parameters. Then you can easily build a query without writing the GSQL language to query the part of the data you're interested in as a return. And the return of those data can be represented in the tabular format. We allow you to configure that. Once you have that, you can switch to a preview to see how these components work with each other. But we don't stop there because graph has much richer meaning and insight in it that you can actually display. And the next part is you can actually build a different dimension of the view using a bar chart showing the history, how things change over time. Of course, being graph, you can build a graph visualization using the same tool. When you combine all these things together, you have a very rich dashboard, including data both in the tabular format, in the graphical format, in the graph format, as well as in the pie chart format. And by having this, you're able to publish this dashboard to business users so they can easily consume the rich insight from this report. So here is the view. When the application is built, you publish the dashboard. That's how business users real-time can query the data. They can see all the different views. They can use a slider to change the value. They can see as a result of that how interactive the value changes. They can drill down through various parts of the data. They can select a different state, and as a result, the query being rerun and bring the latest data to the dashboard. You can see the change. You see how powerful it is with simple tools like this enable the builders, which is non-technical users, business analysts or data scientists, quickly build up dashboard to reveal the insight from your graph, while when they publish that, those dashboards can be easily used by business users, understand what's going on, and drilling down the area they're interested. So the next area is equally exciting, is really this machine learning. What if we can integrate graph insights with deep learning seamlessly, make it effortlessly? And this is what we learn from our customer. There's a journey for people to start from connecting the data, ultimately want to integrate graph with machine learning. So the first step is to connect the data. By simply ingest data from various sources, create this holistic view of data, 360 view, understand how data flows. There's already a lot of value because the data become meaningful. Then you use a very powerful GSQL language to answer questions. What is the shortest path? How are these two things related? What are the similarities between different entities? The next stage, as I mentioned, we have a rich set of graph algorithm libraries, graph data science libraries, for you to easily run, as simple as just drop and click, and then you just run like a function, with almost no effort. You can already get a lot more insight from your data. And finally, this is where the exciting next step is. The latest AI innovation or ML innovation is about graph neural net. The idea is to infuse human knowledge in the knowledge graph with black box machine learning, those neural net. If you combine them together, your model becomes a lot more accurate. You'll hear a lot from other talks today talking about that the huge difference it makes. Model accuracy can be improved as much as 50%. That's game changing. So this particular product, we offer this new ML workbench, allow you to easily, take advantage of all the graph algorithm we have, push down as much as possible the machine learning in the database, but at the same time, extract those graph-based featured insight out of TigerGraph and seamless send to your machine learning pipeline. So this is the tooling we're providing as part of ML Workbench. We give you a Python-based interface. It's a Jupyter notebook, and when you open the notebook, it's just Python code. We already pre-coded how you can connect to TigerGraph, how you can call built-in functions. Python functions already know how to push a lot of graph feature generation to the TigerGraph to compute at scale, and then bring those results back to the Jupyter Notebook so that you can actually send to the next stage, which is the machine learning pipeline, whether being PyTorch, SageMaker, or Vertex AI. You see, by having this approach, data scientists don't have to do a lot. They can immediately take advantage of graph from TigerGraph. Last but not least, can we have all these things running on demand? Right? I don't want to actually configure a big cluster for a lot of time just upfront, just in case I want to run these powerful algorithms. What if I just want to use it for 1 hour? Can I just pay for 1 hour? Yes, you can. Please take a look at what are some of the new features coming on TigerGraph Cloud. So this is, when you actually log into TigerGraph Cloud, you'll see all the solutions they have. Each solution already have its primary cluster, usually configured for data ingestion or for OLTP needs. But what if you want to run a gigantic graph algorithm? It's going to require 10 times more compute and memory. Yes, you can do it on demand. All you need to do is first click on the expansion menu, and we'll ask you, say, hey, we're going to create this compute on demand cluster for you. What do you want to do? Do you want to run this living algorithm? If that's the case, then we already know what kind of compute you need. We project you need 4 instances of this, 16 CPU, 128 gig machine. That's the best for you to run your algorithm. We also show you when you actually have that clustering created on demand, you're going to be paying $28 per hour. This is just an example. So you have completely transparency about how much cost I'm going to incur in order to run that cluster. And then once it's done, then you go to the next stage. We already configured this cluster for you. What do you want to do? When you click on the possible application you can run on it, if you look through the list, it could be running the Graph Studio for you to fine-tune your algorithm. It could be running the Nala tool we just showed you before to do dashboard building. Or in this case, you just want to run ML Workbench. When you click on that, guess what? We automatically create a ML Workbench notebook for you because we already know which cluster data you want to access, you want to process, what algorithm you want to run. So we can already pre-code everything for you. You just need to do a few minor adjustments, click a button, this algorithm will start executing for you on the new cluster. And when everything is done after 2-3 hours, when you get the result, you can easily one single click to shut down the cluster so that you no longer have to keep paying for that cluster. That's the kind of elasticity we are actually going to bring to you on TigerGraph Cloud. So in summary, what we're doing here is keep driving product innovation to power Graph for all. Make it easy, empower professionals in companies of all sizes to take advantage of Graph to unlock smarter insights at scale with speed. Our vision is to be the world's most scalable and preferred ML analytics platform for connected data. And our strategy is we'll keep making our product much easier to use, faster to run, bigger to scale, and cheaper to operate on-prem and in the cloud. Thank you. That's my talk. And what's coming next is equally exciting. Who will be the winners? So our CEO will announce the winner for the $1 Million Challenge. Thank you.